Now let's talk about what is common between all acids and all bases. So for this, what we're going to do is set up an experiment first. Now for this experiment, what you need is a water bath, a rubber stopper, 2 iron nails, 1 bulb and a switch, and some wires to complete the circuit, a switch, and some acid, alkali, some glucose and alcohol. Now let's start with the acid. Now first, let's consider that we are going to use HCl, which is hydrochloric acid. And first off, what we're going to do is we're going to take the rubber cork and we're going to pierce the iron nails into the rubber cork. And then we're going to place it at the bottom of the water bath. After which we're going to pour in some hydrochloric acid solution. We're going to tie one end of the iron to a wire, and the other nail we're going to tie one end to another wire which will go to the switch, and one end of the other wire would be connected to a 6-volt battery. This whole circuit would be completed by placing a light bulb which is connected. Now what we are going to do is we're going to turn this on and let's observe what actually happens. When you have an HCl solution, you see that the light glows. Now let's replace the HCl solution with H2SO4, which is sulfuric acid. Even then, you would see that the contact is complete and you have the bulb glowing. Now let's take an alkali, let's say sodium hydroxide, and you turn the circuit on. After which you see that again you have the light glowing. Now let's take a glucose solution and let's try turning this light on. And even though the circuit is supposedly complete, you switch on the switch and you see that the light does not glow. Now replace glucose with alcohol. You would see the same result. Now why is this so? Now when you have an acid or an alkali, we have talked that they dissociate into ions. An acid would generate an H plus ion and your base would generate an OH minus ion. These are free ions, and whenever you want that you have to complete a circuit or you need an electrical circuit, there have to be some free electrons. Now let's move on and talk about glucose and alcohol. Even though they both have an OH into it and some hydrogens into it, but still they are not acids and bases, and hence they cannot dissociate into H plus and OH minus, and hence we do not have electricity which is conducted. Now that we've been talking about all the H plus ions and free ions and the OH minus ions and conductivity of electricity and stuff, let's also talk about what happens when you dissolve an acid in water or when you dissolve a base in water. Now let's revert back to the characteristics of acids and bases. Now an acid has a characteristic that when you dissolve it in water, it dissociates and gives H plus ions, which can be better called as an hydronium ion due to the reactivity of the H plus ion. Similarly, you have OH minus ions which are given out when a base is dissolved in water. Now base, was it the right word? No. The right word was an alkali. The bases which can dissolve in water are called as alkalis. Now let's just put this to test.
Now for this, we are going to set up an experiment. Now for the experiment, you need the apparatus which are as follows. Number 1, a test tube. Second, a delivery tube, a rubber cork, some sodium chloride, some sulfuric acid which is concentrated, a litmus paper which is blue. Now what you do is, in a test tube you're going to put some sodium chloride, and then you are going to drop the sulfuric acid into the test tube dropwise, that is very slowly. Now remember, this is a neutralization reaction, and hence what we know is it is going to give out certain amount of heat. Now hence you need to go slow with the adding process. Now once you have added the sulfuric acid, you cork the test tube, and remember the test tube has to have an aperture at the top, and then you add the delivery tube into the aperture and you would see some gas which is coming out. Now this gas, as per the reaction, is hydrochloric acid. Now what you do is you take the blue litmus paper and keep it at the mouth of the delivery tube, and you would see no color change. Now what you do is you wet the blue litmus paper and then you keep it at the mouth of the delivery tube again. Now this time you would see a change in color. Now why is it that there was no color change when you had the dry litmus paper and you get a color change when you have a wet litmus paper? Now the reason is simple. What happens is that a litmus paper shows a color change when it gets H plus ions, and H plus ions are not directly available when you have a concentrated solution, or rather a concentrated acid which is not dissolved in water. And as the litmus paper is now dipped in water, it has some water content, and the moment the hydrochloric acid gas comes in contact with the litmus paper, you will see that there's a color change, which is due to the dissociation of the acid and giving out the H plus ions, and the H plus ions are what cause the change in color. Now if you remember, whenever an acid is dissolved in water, it dissociates and gives out H plus ions. A better way of writing the H plus ion is H3O ion, which is the hydronium ion. And this is what actually happens when you have an acid which is dissolved in water.